something new. So taking a look at yesterday, sometimes they give you what I would call related denominators. And related denominators are like 5 and 10. And we said when we want to compare 8/10 to 4/5, we realize that we can change fifths into tenths, right? By multiplying just one side. And what I taught you to do yesterday, I'm going to make it even bigger so that we can really see this. What we can do is we can take and we put parentheses after this to say we're going to multiply. And we go, what times 5 is 10? Class? 2. So this is a review from yesterday. Whatever we do to the denominator, we also have to do to the numerator. I want to start using, and I'll probably mess up, I want to start using denominator and numerator because it's a more proper term, okay? Can we do that? Can we make that goal for us?
Yeah.
Okay, now we just multiply. 4 times 2 is?
8.
8. So this is going to equal, and I'm probably right at that spot, 8. And 5 times 2 is? 10. So here you look, is 4/5 the same as 8/10?
Yeah.
Yeah, there's your proof. Now, why am I showing you the process? Because some of you are like, well, I know it. Well, you might have to show your work when you take like a state assessment test or something like that. They might have something like this. It might not just be click which fraction is equivalent. What's up? That's where I was going to write an 8 there, but that's where the bump in the smartboard is. So I just moved over. So now, these bottom two, though, these are unrelated, I would call them. I know there's probably a proper term for them, but there's no way I can take a 6 and multiply it and turn it into a 10. Do you see that?
Yeah.
So here's the trick with that. I gotta see how far my people on the Zoom can see the board because I want to do it on the board where there's no squiggles, okay? So you're gonna do this with me. On this one, and you might want to do yours over here where you have space to show some work. We have to multiply both of them. So watch. Leave my blank. Braxton, is that still on them?
Yeah.
Okay. Where's my edge?
Like, in the middle of where?
So right here, I have room then.
Yeah.
Okay. And then over here, I have 1/10. You're doing this with me, okay? Because I'm modeling right now. I'm going to do this one, and then you guys are going to use the next one. Here's what you do. We ready? Mackenzie, if I write it down, guess what you should do?
Write it down.
And have you done it? I don't know why. You should do it in that space where you have room to write. That's another thing you guys can do to help me when we're doing digital things. You guys can try and do this stuff and keep up. You're going to find the harder you work, the better you're going to get. Here's what we do. We're going to multiply both of them, so I'm going to put parentheses on both sides. And then you guys are going to go, well, this actually isn't as bad as you think it is. You just take these denominators, flip them. Because 10 times 6 will be
60.
and 10 times 6 will be
60.
Now we'll have common denominator. Now, that's the easiest way to do it. But I am going to show you one more thing for those of you that are maybe at this point. Is there another number that I can count by 6s and 10s and get to? What is it? 30. So another option is if you're smart enough to realize, now we're going to do it this way because this is the easiest way to do it, is to take the other denominator and multiply it. But you could have also taken and multiplied this by 5 and this by 3 and gotten 30, right? But sometimes you're going to come across ones that aren't like that. Like if you have sevenths and thirds, your best bet is just to multiply the denominators. Okay, if I have a 10 in the denominator, what do I need to have here?
10.
A 10. Whatever you do to the denominator, you have to do to the numerator. Very good. You caught yourself. So what do I need up here in the numerator?
6.
Okay, so now watch. So easy. So easy. 10 times 1 is 10. 10 times 6 is?
6.
And if you wanted to, guys, you could have already had your denominator done. Right? 1 times 6 is?
6.
Okay, greater than, less than, or equal? Greater than. Hey guys, I think I've shown you this before, but how to know what the signs are? You just read the sentence. Which one's bigger? This or this? Left or right? Okay, so if this is bigger than, 10/60 is greater than 6/60. This is a greater than sign. You guys see how that works? That's how you tell if it's a greater than or less than sign.
Mr. Ron,
Yeah, Elizabeth.
at the top of it, it says insert, like at the top of those questions, it says like equal or this weird sign.
Oh, well, they're giving you a not equal. This is not equal. I didn't read it. That's my fault.
It's just an equal.
Yeah, this means not equal. We're taking it a step further. We're writing if it's greater than, less than, or equal. You're welcome. I'm making it more difficult. Okay, so now on this one, I'm going to leave this up for an example, okay? Now I want you to compare 5/10 and 3/6. Isn't it kind of the same process then?
Yeah.
Use what I did to compare this. It's either greater than, less than, or equal. I'm going to give you a couple minutes. The key here is to multiply. Okay, who needs more time? I told you. So we're going to start working on it. You guys finish it up. You can check your work as we go, okay? All right. So first thing that I need to do with this is get these ready and then make sure that this isn't falling on the floor. There we go. Okay. Braden, what's the first thing that I need to do to get this ready to go? Very good. Set up my parentheses. Excellent. That's what I was hoping you would say. Okay. Braylon, what's going to go down here? She in there?
I don't know if she is.
She might not be in there.
I believe she is.
I will look. Nope. I have a Delia and I have an Autumn and I have a Parker. Good to know she's not there. Elizabeth, what goes here?
A 6.
Excellent. So, class, what goes here?
6.
Excellent. We're doing a great job right now. Bradley, what would go over here? A 10. So what goes up here, class?
10.
Because whatever you do to the denominator, you have to do to the numerator. Okay, can you, if I do the numerator, Does it still apply to the denominator? Yeah, if I flip flop them, yes, absolutely. Okay, here we go, here we go. 6 times 5,
30.
30. 6 times 10,
60. 60.
3 times 10,
30.
6 times 10.
60.
So these are
Equal.
excellent. And some of you are probably smart enough to realize 5 is half of 10 and 3 is half of 6. But I do want you to practice. I wanted you to practice doing this because we are going, if you can do this now, you're already so far ahead of the game for fractions. The next time we take that STAR test, everybody's STAR test, if you work hard on it and try really hard, your STAR test score should just explode because this is higher level stuff. Okay, we've got a few more problems on this page before I introduce math boxes. Okay, guys, all this is doing is finding the missing number. So we look here, and I've got 1/3. I need to make it 12. What do I need to multiply by here? Delia, what do I need to multiply the 3 by? Yeah, mute, Delia.
The 12.
Yep, I want to make this 3 into a 12. So what am I multiplying by?
6.
What times 3 is 12, Delia?
Uh, 6.
3 times 6 is 18. 2 times 6 is 12. How many 3s to make 12? You got this.
Four.
There you go. Good job. Got it. Okay. If we have a 4 here, we also need a 4 here. Now, I don't need you to solve this side because all you need to do is go, watch. I'm going to save you a step. Saving you a step because I'm super cool like that. 4 times 3 is 12. 4 times 1 is
4.
I don't need you to write it over here. I just need you to finish it. So now, this one. Oh boy, this one is a new one. This time they gave you a numerator. But here's the good news. We can just multiply the numerator and it should tell us what to do for the denominator. What are we multiplying by here, Mackenzie? I'm trying to make this 1 into a, so what needs to go here? You got it. Confidence, confidence, confidence. What goes here, class?
6.
Okay, check this out. 6 times blank is 12. Your turn, write it in. What do we got?
2.
2. You guys finish these 2.
Wait, are we going to do C and F?
Oh, there's a C and F. Just do D and E. You're good.
Yeah.
Just do D and E. We don't have time.
Then should we turn to our math boxes page?
After we go over them, then I'll go over math boxes. Look. When you turn. Yeah, so you're gonna use the smaller one. So what times 2 is 6? 3. So what is 3 times 1? You going to see? Okay. You have a 2 down here though. 2 times 2 is 4. It should be a 3, right? You're kind of on the right. You're kind of on the right path. Okay. The tricky thing with this is I look around. is remember, you always, it's probably easier for you guys to work with the number that's smaller. So in this one, we're working on this side. And on this one, we're going to work on that side, right? And again, all you're doing is it's multiplying. Whatever side this is on, you're multiplying. What times 2 is 6? Class.
4.
4 times 2 is 6. No, 4 times 2 is 8.
3.
You guys were adding. 3 times 1 is 3. Going over here. Something times 1 is 2. Your turn.
2.
Top and bottom, numerator and denominator. I messed up there. Okay. What times 2 is 6? Class.
3.
There you go. That easy. That easy. How are we feeling today? This to 5. This to 5. That means more to me. This one doesn't do it as well for me. Okay, you and I can talk. Okay. I don't have. I've got this in the way, so this video is probably worthless. Because I had your thing up. Okay, it looks real good, Chase. I'll come over and we'll do those 2 extra ones together. Okay, I think it'll help. All right, so let's look at math boxes real quick.
Mr. Ross,
So,
does it show up in the video?
yes, I think so. I think it just records your screen.
That's
So I messed that up, but that's okay. People are gonna have to make do with what they got.
I think it's
Okay. On this one, you're not gonna do B. I'm gonna be nice. You get to do this. I'm gonna be nice and mean. I'm not gonna make you do. I'm gonna let you do the small one, but you also have to do the big one.
So you're just gonna kind of be doing.
Yeah. So here's the example. If you did B, you would go 3,000. I don't have enough room. 500. Maybe I do 90. What if I spell it wrong? It's not a spelling test. I want to just see if you can write it out. Spell it phonetically. Okay. This one, they're asking you if you rounded 5,689 to 5,690, you rounded to the tens place. If you rounded 7,623 to 8,000, you rounded to what place value? And so on. You guys understand?
No.
Who said no? Hadley, look. All of these turned into zeros and this turned into an 8. What place value is that? Oh, you did know that. So here I'd write thousands. You did know. Okay, everyone should get letter B right. I'm going to help you with number 3. We're going to do it together right now. I'm going to write one. You can use it as an example. Actually, I'm going to do it at the end. Do it at the end. Okay, on these, like letter B, you need to change your 10 yards into feet. So you go 10 times 3 and get your answer. Then you have 1 foot here, so you have to add 1. You guys understand that? On letter C, you have 4 feet. You need to change that into inches. That's 4 times 12. Get your answer, and then you need to add 7, right? Down here, you gotta change your 2 hours into minutes, so 2 times 60. Then add the 30. It's 2 steps.
Which ones are we gonna need to do?
All of them. I have faith in you. People here, I'm gonna give you the time after lunch to work on it. And any free time. This one, I want you to do both. You should be able to add and subtract. Okay, I'm gonna review prime and composite because this should be easy too. Prime has exactly 2 factors. 3 is prime. The only way you can multiply and get 3 is 1 times 3. 5 is prime.
Mhm.
1 times 5. 4 is not prime because you can get that by going 1 times 4, 2 times 2. So 4 is a composite number because it has 3 factors. 1, 2, and 4. Braxton.
Most of the odd numbers are prime.
Uh, Let me put it to you this way. All prime numbers are odd
Except
except for 2. 2 is the only prime even number, but not all prime or not all odd numbers are prime. Here's an example. 9.
composite.
1 times 9, 3 times 3, composite. But all prime numbers except for 2 are odd.
Odd.
Okay, questions, comments, or concerns? Okay, Zoomers, we'll see you at about 12:30.
Bye.
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 Whatever goes here. Goes there, right? 2 times what is 6? Good. Now, which one's smaller, 4 or the 8? Where's the parentheses go then? Yeah, very good. Now, what times 4 is 8? Top and bottom. Now multiply your denominator. Not both numbers on the side. 2 times 4 is 8. The only reason we had to ask on this one is because whatever side it's on, you just multiply straight across. Okay? So you're going right to here. What did you get? 2. No, because the 6 is on the same side. Oh, this is our 1 on the equal side. 2 times what? You will. 2 times 4 is 8. What are we going to do here? 2 times. It's equaling this. What are we multiplying 2 times? No, the 8 over here. The 8 is what it's equal. These are different sides. 2 times 6 is 30. You see? Yeah. So whatever side you have the 2 of them on, that's what you multiply. Now you might have a blank over there like this one, where you 2 times 5 is 10. You already know what you want to equal. You just got to figure out what you multiply with 5. Okay? Make sense? Where are you now? Just 5. Okay. You want to do one more before we go? I'll make one up. You can do this. Mhm. Okay. Now, what times 7 is 21? It's 10. 3 times 7 is 21. Okay? So now, because we're trying to equal 18. Very good. What is 3 times 7? Let's line up for recess. That's not enough. We are 4 now. You feel like you're 4, you still have 3, 4. 4? Good. And we're trending in the right direction. Good. Okay, when you get back, I highly recommend that I highly recommend that we get right to work